Hello, Mr. Molecule, Mr. Atom. Where are you? I can't see you. Somebody told me that there's atoms and molecules in this thing. I can't see it. It just looks like water.
Mr. Brown? What are you doing?
Oh, well, somebody told me that there's atoms and molecules that's making up this water in here. I don't see it.
So you want to learn more about atoms and molecules, do you?
Yeah.
Okay, wait right here. Mr. Brown wants to learn about the molecules and atoms that are involved in water, and we can't actually see those, but let's find some ways to actually represent and learn what makes up that water and help Mr. Brown and the 6th graders learn more about atoms and molecules and what they're made of. Okay, here we go. All right, Mr. Brown, so if you set that beaker down,
okay.
it's not going to help you see the molecules better because with our human eyes, we actually cannot see the individual atoms or the molecules. And there are 1 million atoms that can fit on the tip of that pin. Whoa! They are incredibly tiny. So, inside of that beaker, you've got hydrogen atoms, which I'm going to represent on this table with these marbles. And they connect to oxygen, which I'm going to represent with this big bouncy ball.
It looks like Mickey Mouse.
It does look like Mickey Mouse. So what we notice right here is we have 2 hydrogen atoms, that are the marbles, attached to 1 oxygen atom that is the bouncy ball. When we put those 3 things together, we have a molecule of water.
Oh, so atoms combine to make molecules.
Yes, they do.
Kind of like if I spell my name, B-R-O-W-N. That's like kind of like combining letters to make words.
That's exactly what it is. It's combining different atoms together to make different substances that we call molecules.
Now, those are in here.
Those are in there. Now, the smallest, tiniest piece of water, if you wanted to get the tiniest drink of water you could possibly get, you would have 1 molecule of water. You can't have 1 atom of water because water is not something that's listed on the periodic table.
Sure.
Right? The molecules are made up of those atoms. So if we took this apart, here we'd have 1 atom of oxygen.
Ooh.
And if we took these apart, we'd have 2 atoms of hydrogen. So now they're individual atoms. When we put them together, they are molecules. For that.
Cool.
Now all of this is going around, and it comprises everything that we know of as solids and liquids and gases that are go together to make matter.
Oh, okay. So matter, everything we know is made up of matter.
Everything is made up of matter.
Okay.
And those individual atoms, in which 1 million can fit on the head of this pin,
Whoa.
are mostly comprised of empty space.
Empty space. So there's a lot of space in between these atoms and things?
There's a ton of space in between those.
But it doesn't seem like a lot of space because they're so small.
They're so incredibly tiny it doesn't seem like a lot of space. So if you kind of take a look at our graphic, you would see that we have different parts of a single atom. All right? So there we go.
Cool.
Now, in the center of that graphic, you have something called the nucleus. And that's where we get our term called nuclear power.
Ah.
You can do a lot of different things with the nucleus that releases a ton of that power. Now, notice going around that nucleus right there, yeah, we have little tiny particles that are called electrons.
Ah.
So if you ever get zapped by electricity, that's a stream or a river of those little tiny electrons that are going around that nucleus. Isn't that cool?
Yeah.
Electricity, electrons. Now, let's go back to the center of that atom where most of the mass happens to occur. There are 2 main particles in the center of that atom that you can see. Those are the protons that have a positive charge and the neutrons that have a neutral charge.
P positive, protons, and neutral, neutrons.
You got it. Yeah. Even though we can't see them, they're right there. Matter, made up of a lot of empty space. So, if we go back to our parts and things like that, we have those protons and neutrons are inside of that nucleus. and those electrons are going around the outside to comprise our parts of the atom. So now, Mr. Brown, you probably know the difference between a single atom and a molecule.
Mm-hmm.
And we can tell some of those parts of a single atom as well.
Cool.
And we know a chemical formula, when we put those atoms together for a molecule, is a sample of H2O, because we have two H's with those marbles.
Yes, yes.
And we had the O as the bouncy ball for oxygen.
Very cool.
So, do you think you have it, Mr. Brown?
I think so, but you know, as usual, sometimes we need to make sure our students have it too.
Ah, yes we do. So I know what we need to do. Let's review!
Everything around us is stuff, and all this stuff is called matter.
Particles that are too small to see or uncuttable are called atoms.
Atoms are mostly empty space.
Atoms are so small that you could put 1 million on the head of a pin.
Atoms combine or chemically bond to make molecules, just like letters combine to make words.
There are several parts to a little tiny atom. The center of a little tiny atom is called the nucleus.
The two particles inside the nucleus are the protons with a positive charge and the neutrons with a neutral charge.
Orbiting around that nucleus are electrons, and electrons have a negative charge.
We can determine which atoms are bigger by their atomic number. Remember, we looked at hydrogen atoms would be represented by a marble and oxygen by a larger bouncy ball, because oxygen atoms, even though 1 million of them could fit on a pinhead, are larger than a hydrogen atom.
And the difference between a single atom and a molecule is that a single atom is one pure substance, and atoms go together to make those molecules. Just like Mr. Brown's example of water. H2O is a molecule.
The H2O is 2 hydrogen atoms chemically bonded to 1 oxygen atom, like we saw in our model.
Well, 1 million of those atoms on the head of the pin?
Probably millions, billions, trillions of atoms and molecules in this beaker of water.
Actually, a number with trillions of zeros after it in that beaker of water is right. Well, I hope you learned a little bit more about atoms and molecules and some of the chemical formulas and what an atom is made of. So that's about all the time we have for you today on the Know Your Science Short. So, see ya!